Okay, example one here has us graphing a phase shift. So they want us to state the amplitude, period, and phase shift for y equals cosine of x minus 270. Okay, so first of all, x minus 270. That should so cosine of x, should be our at least one cycle of the cosine of x. We should start up at 1. We should go down to -1 by the point that we've done half of our cycle. Um, and we should be back up to 1, having completed our cycle at 360 degrees. So if we are shifting, if we're going to subtract 270, keep in mind that taking away something from the x value shifts us to the right. I keep pointing right, but I think my camera makes it look like I'm pointing left, so I'll stop pointing. So 270 degrees to the right. So rather than starting right here, we are going to start at 270. So we would start there, and we'd basically, I can just take this thing actually. Can I? Did this before. There we go. So that would be our phase shift. We would just be moving it so that we would start at 270 degrees, and then you could, continue this down if you wanted. Now, going to the right by 270 degrees, there's another way we can do that. So keep in mind that if you want to add 270 degrees and get down to 270, well, you could also get there by subtracting 90 degrees. That would in effect put you in the same position. So we could also say that, okay, so that's 180, so let's call like this negative 180. Let's call half that distance negative 90. Should also be able to just move to the left by 90 degrees and have things work out to be the same as if you moved it to the right by 270 degrees. So in this case, asking about all these things, so they give us they ask for the amplitude. Well, we don't have any a value here to multiply our outputs, so our outputs are not getting any bigger than the traditional 1 and -1. So we still have an amplitude of 1. The distance from the midline to a maximum or minimum is still 1. The period has not changed, so we still have a graph that is cycling every 360 degrees. It's just in a different phase of that cycle at x equals 0. So the period is still 360 degrees. Now, keep in mind they say the period is always found by doing 360 divided by your b value, absolute value of the b value. And keep in mind how they structure this equation. So the b value is not on the inside. This isn't necessarily relevant for the example we're on right now, but it will be relevant at some point. So the way that they wrote this out is like this, which means that if you ever saw an equation that, for example, had, let's say 3x minus 9, something like that, in order to get your b value, you don't want to just say b is 3 and call that the end of the day. You want your b to be on the outside of the parentheses. And the reason that is important is because once you've gotten it outside the parentheses, you're going to change the value of that horizontal shift. Okay, so that horizontal shift value, it's only the thing after the x when the x is by itself. So if we have 3x minus 9, we are not shifting to the right 9 units. We're actually shifting to the right by 3 units. Okay. So that's just an important distinction to keep in mind when you're looking at those equations and trying to parcel out what your horizontal shift is, what your period is. But for this one, the amplitude hasn't changed, the period hasn't changed. The only thing that's changed is the phase. The phase has shifted by 270 degrees to the right. Or, if you wanted to say it differently, it is shifted by 90 degrees to the left. But that is basically it. So let's just go in real quick and just verify that. So if I do cosine of x minus 270, and I have taken the top of my curve and I have moved it over to 270. Okay, so we've shifted to the right by 270. If I wanted to do the same exact thing, because these are periodic functions that repeat over and over, I can end up in the exact same place if I shift to the left by 90. So if I take this one out, we should just see one graph, right? So regardless of whether we're calling this cosine of x minus 270 or we're calling it the cosine of x plus 90, we end up with exactly the same graph. Okay, so that's the important idea that these cycles repeat. So like I can say x minus 270, or what's 360 bigger than that? 5, 600, 630. I should be able to say minus 630. That shouldn't change anything. If I did another 360, so if I did 990, that should be the same, right? So we're talking about how much we're shifting. The amount that we shift might end up giving us the same looking graph. That was never the case with like a linear equation, right? There was no sense in which I could take y equals 3x plus 5 and shift it so far. Oh, my units are all off, so it just looks like a straight line up and down. Well, there was no way that we could shift it to the left so far that it wrapped around and just looked like what we started with, right? Okay, that's the difference between a periodic function and a linear function. Okay, so I think that's good for example number 1. We'll take a look at example number 2 in the next video.